Okay, hi everyone. This video is going to cover 8.2, perimeter and area of composite figures. But I'm actually going to take a detour and start with something else because I think it's very, very important. What is it? I'm going to revisit area, surface area, and volumes that you may have encountered in the prerequisite that I asked you to try, page 416. It's super important. Let's start, just right off the bat. You might want to bust out a piece of paper for this one, for sure, as opposed to filling in just a note sheet just to fill in the blanks. It's not the same. I really want you to consider this. When we talk about area specifically, right, we're generally assuming that it's going to be a 2D figure, right? A square, it's flat on the piece of paper. Triangle, it's flat on the paper. A circle, it's flat on the paper, so on and so forth. It's always going to assume it's 2D. When we jump to surface area and volume, all of a sudden we're dealing with 3D figures. But you know what? Up until now, you may have just memorized formulas for surface area, volume, and whatnot for 3D figures. I want us to actually break down 3D figures and think about them very simply. 3D figures is basically 2D figures glued together. Okay, and some of you might already see where this is going. The reason why I talk about 3D as 2D figures glued together and getting you to think about it this way is because composite figures is nothing more than that. If you can understand the concept that I'm going to talk about in just a second, perimeter and area of a composite figure, that's a cakewalk, right? That's light work. That's easy sauce. So let's do it. We are going to start with me talking about a triangular prism. Okay, watch me draw this. Okay, maybe. Here it is. Basically, what I'm trying to draw for you is a box for a Toblerone bar. You guys know what I'm talking about. Toblerone bars come as a rectangular prism. Typically, when you get to, I guess, Christmas time or winter holidays, you start to see these huge triangular blocks come out of nowhere. And they're on sale, and they always get you to buy it, right? So if I asked you straight up, what is the surface area? What is the volume formula? Just the formula, not even the actual number. What is the formula for both without looking at a formula sheet? Would you be able to piece together what the actual formula is? You should. Let me try to explain. To get you to understand, let's start with surface area. To get you to better well, actually, I take that back. I'm not even going to talk about volume. And we're going to get to volume sometime later on in the later ends of chapter 8. So right now, let's just talk about surface area. Can you give me the formula for a surface area without looking at a formula sheet? I'm going to get you to try to look at a 3D figure as if it was a whole bunch of 2D figures. So just like how a Toblerone bar opens up, let's pretend you take this little triangular lid of the Toblerone bar, and you're gonna pop it open. And what do you get inside? It's just darkness. Why? There's chocolate inside, right? It's a hole. And the same thing on the bottom. I am going to flap open, right, the bottom lid. So now I have a triangular tunnel with a triangle top and a triangle bottom flap, sort of, and it's hollow. Let's pretend it's hollow, right? Because I'm only talking about the surface here. If I had a coin and I sort of let it drop, it would fall right out. I hope you got the point. Surface area. Can you calculate the area of a triangle? Can you multiply that by 2? Can you calculate the area of the other triangle? By now, you probably were this was regurgitated onto you to the point where you got sick. The formula for an area of a triangle is half times the base times the height. So if you know the area of a triangle, you already have basically half of the surface area of this triangle. So the next part is this. How do we deal with the body? Right? That was terrible. But in any case, The best way to describe it, I'm gonna get you to try to visualize with me. Let's pretend I take scissors, okay? And I'm going to cut one of the corners right along the corner, okay? What does that turn into? Well, it's gonna be something like this, right? Let's see if I could draw that correctly. If I were to cut this open, it's no longer a tunnel. It's just 3 rectangles. It's gonna start to, I'm gonna take these 2 flaps and I'm gonna open them up. And if I do that, in essence, I'm gonna get myself, wow, could I get any more lazy? I'm going to get myself 3 separate rectangles. Sort of like, I don't know, sort of like, geez. You know these, if you've ever gone to, you know, fix up a suit, maybe in your grade 10, grade 8 graduation, you might have had to fix up a suit, or you went to a special store and they get you to stand in front of a whole bunch of mirrors, right? It could be something like that, right? Now, I know I did a terrible job. You're gonna have to forgive me for that. But essentially, this is 3 rectangles. And I know the dimensions aren't given to you, but do you know how to calculate the area of a rectangle? Yeah, it's just length times width. Or in this case, whatever this length might be, or whatever this width might be, multiplied by how long that Toblerone bar was. If you can calculate rectangle 3 times, if you can calculate a triangle 2 times, you basically have the surface area of a triangular prism. That would be 2, I guess the 2 times the area of a triangle plus 3 times the area of a rectangle. Now, I know I'm oversimplifying. Sometimes the dimensions of all 3 triangles may not be the same. Sometimes the dimensions of these 2 triangles may not be the same. But again, I'm just trying to deliver the point that you don't need a formula. You can actually piece each section out and calculate it. The same applies for a cylinder. Okay, so I'm going to try to draw this. Bear with me here. Let's pretend I have, it's sort of like a Pringles can. Say I have a cylinder, right? If I were to pop open the top and pop open the bottom like so, right? And this becomes just an empty tube. Can you calculate the area of a circle? I hope so. Pi r squared. Right? So all you have to do is calculate the area of these 2 circles, which is pi r squared and pi r squared. All that's left is, as I usually did before, is the body or the tube of this cylinder. How do you calculate the surface area of that cylinder? Well, just as I did before, I'm going to take a pair of scissors. And I'm going to cut through the tube anywhere. And if I were to take that tube and sort of open it up, it might look something like this, right? And I'm going to open up these flaps, and guess what shape that actually takes? It's like a flat piece of paper. Try it. Take an 8 by 11 piece of paper that you might have in your printer and roll it up. You'll get a cylinder. The body of a cylinder is actually just a rectangle. So what's the area of a rectangle? It's length times width. The only difference is, what is a length of this rectangle, it happens to be the height of the cylinder. And what's the width of that rectangle? It happens to be the rim of the circle. In other words, the circumference, or C, right? So what is the area of a circle? Sorry, what is a surface area of a cylinder? It is 2 times the area of a circle plus the area of the rectangle. But if I were to write out the actual formula, it was 2 times half base times height plus, what is the height of the rectangle? I'm just going to call it h, multiplied by, what's the circumference of a circle? 2 pi r. If you look at the formula sheet, this will be simplified as, so again, base, oh shoot, what am I doing? Sorry. The area of a circle is not half base times height. I was looking at the left side and I made a mistake. Sorry. The area of a triangle is, area of a circle is pi r squared. Sorry. Oh my goodness. If I were to simplify this, you would get 2 pi r squared plus 2 pi r height. Again, sorry about that. Why am I getting you to look at 3D structures as if it was pieces of 2D structures? Well, as I said before, understanding that 3D figures are 2D figures pieced together will help you with the idea of composite figures. I'm going to erase all of this, get you to try 2 questions together, and then I'm going to assign you the homework that you see on the top right corner. If you don't want to wait for me as I erase all this, please use a timestamp on the comment section, or the, I guess, the information section, and jump to my explanation. Okay. Whew, took a while. All right. If you have the textbook on you, and you should, take a look at page 427. This is exercise 1. Okay. They give you a pretty weird shape, but they give you all the dimensions out there. Okay, that's 1. That's 2. Okay. Here it is. They're asking you, what is the area of this shape? Now, you could try to employ the area formula of a trapezoid. But again, if you don't have a formula sheet, there is a way around it. Consider how that shape is actually 3 simpler shapes pieced together. And you need to develop an eye for that. Can you calculate the area of the first shaded image? Well, yeah, not hard to imagine. You know the formula, half base times height. Can you calculate the area of a rectangle? Yeah, that's not hard to commit to memory, length times width. Can you calculate, again, the area of a triangle? Half base times height. If you're able to look at large, weird, or unfamiliar shapes as pieces of simpler shapes, you're pretty much done. So let's do this. I'm going to call this shape 1, call that shape 2, call that shape 3. So the area of shape 1 is going to be half base times height, because it's a triangle, half times the base times the height, is going to be 696 units squared. The area of part 2 is going to be, well, length times width because it's a rectangle. That is 16 times 24, which is something I can't unfortunately do in my head. Which I also apparently get 384. And the area of number 3 is going to be half base times height, which is half 4 times 16, which is 32 units squared. So the area total of the entire shape is going to be 96 plus 384 plus 32, which is 512 units squared. Okay. Seems simple enough, but what if the question got a little bit more interesting? Like, for example, I'm going to draw your attention to page 429, example 2. They give you a very interesting shape that is not typical, like that. Okay, you have to assume that's going to be a perfect semicircle that has been bitten off. Okay, the height, or rather the long length of this funky shape is 5.2, and the width is 2.1. Part A. Go about explaining how you would actually calculate the area of this funky shape. Is there a formula for this funky shape? No, not even in a formula sheet. However, there are ways around it. Please consider that this, if we didn't have this weird piece bitten off, that's actually a complete rectangle. And assuming that this is a rectangle, well, it is a rectangle, you don't have to assume. You can say that the area of this entire blue section is going to be length times width. But we know that this portion of the blue triangle is not to be counted. Well, how do you calculate how much we need to, quote unquote, bite off so that it's not counted? Well, again, pretend we took some scissors and we cut a perfect semicircle out of it. So in essence, subtract half a circle from a whole rectangle. And so I'm going to do that. What is the area of the rectangular portion? Well, length times width, which is 5.2 times 2.1, 10.92 units. What is the area of the entire circle? Well, it would be pi r squared. Ooh, I need the radius if I want the area. Luckily, we have the length to be 2.1. So if I take 2.1 divided by 2, the radius is going to be 2.1 divided by 2, 1.05. So the area is going to be pi times 1.05 squared, which is 3.46 approximately. All right. Since I'm not taking out an entire circle, but I'm actually only biting off half of what it ought to be. So area of half of that circle is, divide that by 2, approximately 1.73 units squared. Therefore, let's see. Therefore, the area of the total figure is going to be 10.92 minus 1.73, which is 9.19 units. That's how much that shaded, funky looking shape is going to be. Okay, so sometimes it doesn't have to be adding. Sometimes we can get creative and do subtractions to get the side that we want. Part C asks, what is the perimeter of that shape? So I would have to add 5.2. I would add 2.1. I would add 5.2. And then I got to figure out what distance I actually traveled. And this time we're not talking about area. This is half of the circumference of a circle. So let's calculate that. Area of, what am I doing A for? Circumference is going to equal to 2 pi r, which is 2 pi 1.05. 6.597, so approximately 6.6. Okay. Half of that is going to be 3.3. Therefore, the perimeter is 5.2 plus 2.1 plus 5.2 plus 3.3. 15.8 units, not squared. Again, I might have taken you off on a bit of a wild goose chase by trying to explain all that surface area and stuff in the beginning, but I recommend you watch the video again, because if you understand, again, that larger complex pieces can be discussed or can be looked at as a combination of smaller, simple pieces, a lot of the calculations you do, no matter how difficult the question, you could probably figure them out by bringing it down, or I guess lowering it to easier, manageable shapes. Okay. You can test your mettle by looking at the questions here. Okay, page 432, numbers 1 to 4, 8, 10 to 13. That's our week's work. Please do your best, ask me questions, and hopefully we'll see you soon. Take care.